So we did transformations actually in chapter 2, where you guys were moving like up, down, left, right, stretch, compress, flip, all of that. We're going to do some more of that today. So you're going to have to call back your knowledge from chapter 2. The first thing that we're going to start off with would be writing quadratic equations in vertex form. All right, so your vertex form looks like this. I just want to get this written in front of you. So y equals a, and then we've got this quantity x minus h squared plus 5. Okay, so when you're looking at this, you can see all the transformations that would be happening. So what this does right here, this is either a stretch or compression. This is a movement either left or right, and remember it's always the opposite of what you think it's going to do. And then this would be a movement up or down, and it does exactly what it looks like it's going to do. So what that means is, since normally quadratic functions start right at the origin, like this is kind of your original quadratic. This is just y equals x squared. If you move h units left or right, and if you move k units up or down, let's say that we've got some sort of new parabola like over here. Okay, so say I shifted it h units left and then shifted it k units down. My vertex would now be at hk. So once it's in this form, it's super, super easy to see what the vertex is. So that's kind of the perk to writing things in vertex form, in case you're wondering. It makes it super easy to graph because you know exactly where the vertex is going to be. So we're going to do a little bit of practice with this. So this first one is a little bit easier because I just have an x squared, and my technique is going to be really, really similar to what I did with completing the square. Okay, so completing the square helps me to write this perfect squared term like this, and then I'll probably have something floating on the end. So I keep my y on the left-hand side, and then I'm going to take these pieces, and I'm going to complete the square on these pieces, just like I did a few sections ago. So I've got this 4, and the 4 isn't the right value. It isn't the number that completes the square. But instead of moving it over here, because I only want y to be by itself on the left-hand side, I'm just gonna kind of move it over. All right, just push it to the side, figure out what I need to complete the square. So I'm gonna focus inside the parentheses for just a moment, and you can see how this is starting to take shape, because this is gonna turn into a perfect square, and then I'm gonna have some sort of number hanging out on the end. All right, so the process works the exact same as it did a few sections ago. You take that middle number in front of the x, you cut it in half, so here I get -1, and then you take that number and square it. Okay, so that gives us 1. So I'm going to add 1 right here. So 1 completes the square. So remember I told you that we're not going to do anything to the y on this side. So normally if I added 1 to the right, I'd add 1 to the left and keep the balance. I'm going to do things a little bit differently because I need to stay all on the right-hand side here. So to keep the balance, what I do is I add 1, and I balance it by subtracting 1. So that's how it's going to work when we're in this section. So now let me rewrite. I've got y equals. I can write this just the same way as I have in the previous sections. I can write this as x minus 1 quantity squared, and then simplify this up. So this is plus 3. So this is my equation rewritten into vertex form. Okay, so my equation for this, my vertex for this would be +1, -3. Because when I am in this form, the x value of my vertex is h, and this is always going to be x minus h, and the y value of the vertex will be k. So just a fun fact, we'll be using this in the next video. The vertex is +1, +3, because this is always opposite of what it looks like, and this is exactly what it looks like. Okay, let's do this one here. Y equals, I keep my quadratic term, I keep my linear term. Rather than moving this over to the left-hand side, I'm just going to push it out of the way. Okay, so now I want to take this right here and I want to complete the square on it. So think back to your completing the square. What we're going to do is we're going to factor this out, because remember I cannot have something in front of the x squared. So this step is super, super important. I cannot have anything in front of the x squared, so I'm going to factor it out. This is a similar step to dividing both sides, but again, I'm not touching this y. So it's kind of like an analogous idea here. Rather than dividing both sides by the -3, I'm just going to factor it out. So I'd be left with an x squared. If I take -18x and factor out a -3, I'd be left with a +6x. Okay, leave some space because I still haven't figured out what number is going to complete the square. Okay, so now I do the same step that I did up here. I have 6, and I'm going to cut it in half. That gives me 3. and then I take 3 and I square it, and that gives me 9. Okay, so 9 is my magic number that completes the square here. Remember though, I can't just add 9 where there didn't used to be a 9 before. Okay, here's the tricky thing with this one, the one that has a -3 on the outside. This isn't really a 9. Looks like a 9, acts like a 9. However, if I were to redistribute this -3, I would have -3x squared, -18x, all what I have up here, -27. So again, while it looks like I added a 9, what I actually added to my equation that I didn't have before was a -27. So I keep the balance by adding 27. Okay, so again, what I really added was a -27, so I balance it out by adding a +27. Okay, so now let's clean this up. So y equals, I have a -3 on the outside. This I can factor down to x plus 3 quantities squared, and then this is going to be a 37 on the outside. So that is my equation in vertex form. The vertex of this, remember x is opposite of what it looks like, so -3, and then the y value is exactly what it looks like. And if we were going to graph this, this would be upside down and stretched. Okay, so I think, yeah, we've got one more for this video. Okay, so we can do some equation writing with this. So if you know the vertex and one additional point, it's going to look something like this. So let me write my equation first. Okay, so if we know the vertex, this -1 and -2, those are the vertex. That's going in for h and going in for k. And then I have an additional point. And my additional point, -4, +13, this is like a sample xy. So the -4 can go in as a sample x, and then the +13 can go in as a sample y. So I'm going to plug all 4 of these values into this equation. And then what I'll be able to solve for is a. So y, my y value is 13. I don't know a, I'm trying to find it. X is -4 minus h, which is -1, so minus -1 squared, plus k, so plus a -2 or -2. Okay, so all I'm going to do is I'm going to clean this up, solve for a, and then resubstitute everything back into the equation. So I can add this 2 to both sides. I get 15 equals a times -4 plus 1 is -3. -3 squared is 9. So divide both sides by 9 and I will get a. So I can reduce this down by 3 and I get 5/3. So I know that a is 5/3, so it's not this one. And it's not this one, and I'm hoping it's this one, because it's not this one. And you can check your vertex is -1, -2. So this is -1, because remember it's the opposite of what it looks like, and then -2. So that would be your answer. Okay, so now in the second half of 4-7, we're going to be looking at the transformations. So remember in 2-7, I don't know if you do remember, it was a while ago, in 2-7, we focused on transforming graphs based on these 3 original points that their graphs had. So I'm going to walk you through these translations again. So this is the vertex form that we've just been working on. So horizontal translation is either left or right. So the horizontal translation all depends on h. Okay, so that's the number that's inside. Remember, anything that's inside always goes left and right, but it always does the opposite of what it looks like it's going to do. So let's say that you have an x plus a number. That means you're going h units to the left, and if you're going h units to the left, you're going to subtract h from the x values. Okay, so if you're moving h units to the left, that means you're going to subtract h, whatever it is, from all the x values. And then if you have x minus h, remember it's always kind of counterintuitive, you're actually going to be going h units to the right. Okay, so if you try to move to the right, then you're going to be adding h to all the x values. Okay, so that's a left-right transformation that affects the x value. Vertical translation has to do with this value of k right here. And when it's on the outside like that, it actually does do exactly what you think it's going to do. So if you have a plus k on the outside, then you're going k units up, which means you're going to be adding k to all the y values. And then if you have minus k, it goes down. So k units down, which means you're going to be subtracting k from all the y values. Okay, next is reflection. Reflection has to do with that value of a. So it has to do with a, but mostly if a is positive or negative. Okay, so if a is positive, then it's going to be right side up. Okay, so it's going to look like this. And there's no change made, because that's kind of the default setting, is that it would face up anyway. So no change would be made if a is already positive. But if a is negative, what that means for our graph is that it's going to get flipped upside down. And flipping upside down, remember from a couple chapters ago, that means that all the y values are going to become negative. Okay, so we make all the y values negative. And dilation, finally, the dilation also has to do with a. So a might be like a fraction or a whole number, or it might be negative too. So that's going to do, it's going to stretch or compress our graph. So if a is a whole number, like if it's bigger than 1, it's going to stretch the graph out. And if a is somewhere between 0 and 1, then it's going to compress the graph, kind of like squash it down and make it wider. Okay, so either way, no matter what your value of a is, what you're going to be doing is multiplying y by a. Okay, so here we have like exactly what those transformations are going to do, and then in parentheses I wrote how to transform those 3 points. Okay, so with this graph right here, you've got your original 3 points. Okay, so quadratic graphs, the original 3 points. And we saw this in 2.7, but like I said, it's been a while. We've got the point -1, 1, 0, 0, and 1, 1. So those are the 3 points that you're starting with. And then these points right here, these transformations are going to affect what the new 3 points would be, and then you can graph them. Okay, so we've got 2 examples. That first, what we're going to do is get them into that vertex form. So I want to write what that vertex form is, just so we have it on the screen in front of us. Okay, so this one, not in vertex form. Anytime you can see the linear term like that, it's not in vertex form. So we're going to complete the square and get it into vertex form. Okay, so that looks like this. We have y equals. So first thing I want you to notice, this a right here is going to be whatever number was a in standard form, because in standard form we have ax squared. So since the a is written on the outside like that, we need to factor that term out. So we're going to factor out a -2, and then we have just an x squared left. Make sure you're factoring the -2 from this middle term as well. So when you divide that by -2, we're left with -2x. Now here's the trick. We're actually not going to touch this constant term right here. We're just going to leave it floating on the end, because see, we have a constant that's floating on the end here. So in order to get it into this binomial squared like that, we need to complete the square. So I'm going to leave that, because I know I'm going to be adding something else. And like I said, this +1 just kind of got pushed over to the side. Okay, so now when we complete the square, we're going to start with this middle term. Think back to 4, 5. Start with this middle term, cut it in half. That gives you -1, and then square it. Okay, so when we do that, so we start with that -2 in the middle, cut it in half, that gives us -1, and then when I take the -1 and square it, it gives me +1. So I'm going to add a +1 right here. So these are the completing the square steps that I just did. So I just added a +1. Now here's the part that really throws people off, and it probably was messing you up during the completing the square too. Even though obviously what I just wrote down on this paper was a -1, in the context of the equation, it's not a -1. It's actually a -2. I'm sorry, not a +1. It's actually a -2. Because if I were to redistribute this -2, this, when I multiply it out, would actually leave me with a -2. Okay, so I just changed my equation. I just threw a -2 in there that didn't used to be in there. So when I was doing the completing the square, if I had a -2 on the right, I'd put a -2 on the left. I don't actually want to do that here. I want to balance on the same side of the equation. So since this is a -2, what I'm going to do to offset that -2 is I'm going to add 2, like that. Okay, so let's clean that up, get it into our vertex form. So y equals, I've got a -2 right here. this factors down into this form. It's x minus 1, x minus 1. So I can write it as x minus 1 squared. And then this combines to give me a plus 3. Okay, so that's my vertex form. You can see all the pieces are in order. So I start with my original points. So I'm going to write O for original. These are my original parabola points. They're always going to be these 3 points. So don't ever have to worry about memorizing something different for parabolas. And so then I'll write N for new. My new points start off with this in the middle. This is the only thing that ever affects the x. Okay, so here's what I have on the other page. I have an x minus 1, which means I'm going 1 unit to the right. So if I'm going 1 unit to the right, I'm going to add 1 to all of my x values. Okay, so start with that. So add 1, add 1, add 1. Okay, so that's the only thing that affects my x values. So now I actually have 2 things that affect my y values. Okay, I'm always supposed to be multiplying my y values by this. So that's if I have a right here, I'm supposed to be multiplying my y values by a. And then if I have a number right here, then I am supposed to be adding k to the y values. Now move from left to right. You always do this first. So first, I'm going to multiply my y values by -2, and then I'm going to add 3. Okay, so multiply this by -2, I get -2, and then add 3. And it actually takes me right back to 1, which is kind of weird, but you'll see what ended up happening there. Multiply this by -2, and I still have 0, and then add 3. And multiply this by -2, it gives me -2, and then add 3, and it takes me right back to 1. So all you need to do in order to graph is just plot these 3 points and connect the dots. Okay, so 0, 1 will be right here. 1, 3, it's right here, and 2, 1, right there. So you can see that even though these 2 points were the same, the graph got flipped upside down, it got stretched, it got shifted. So you can see here, this vertex, the vertex is the point 1, 3. And when you're in that vertex form, you can read it right off the equation. +1, +3 ended up being the vertex. And then this -2 flipped it and stretched it. Okay, so let's look at one more here. This one's actually already in vertex form, technically. There's no linear term, so that means it's already in vertex form. If you see a linear term like that, you're going to have to rearrange it. But so this, like, a is 2. All this means, like, this is already just an x squared. So that just means that h is 0. And then 7 would be your k. All right, so this is already in vertex form. So I'm just going to start with my original 3 points. And then I'm going to do my new transformed points. So since h is 0, that means it's not moving left or right. So I don't have to change my x values at all. I'm just going to keep the same x values. And then remember, first for my y values, first I multiply by a and then add k. So start with 1. First multiply by 2, that gives me 2, and then add 7, so 9. 0 times 2 is 0, plus 7 is 7, and 1 times 2 is 2, plus 7 is 9. So if I just plot these 3 points, then I will have my graph. Okay, so I know I've got big y values here, so I don't need to bother with any negative y values. 8, 9, there we go. Okay, so -1, 9 is going to be all the way up here. 0, 7, and 1, 9. It's right there. So connect the dots, make a parabola. Okay, you can see the vertex right here is 0, 7, which again, since this was in vertex form, you can just read it right off the equation that the vertex would be 0, 7. And then it kept it right side up because the a is positive, but it stretched it by a factor of 2.